to Calbeckistan, the place where everybody can learn math. I'm Mr. Calbeck, and this is our second video in the crash course on factoring. Last time, we learned about how you can take a quadratic expression like this, and you can factor it into this. And you can take this last term here, and if you figure out the two numbers that multiply to make 8 but add to be 6, the middle term, you can figure out what goes in the two factors. In this case, 4 and 2 multiply to be 8 and add to be 6. In today's video, we're going to be looking at something a little bit more challenging. We're going to be looking at what happens to see if you have a number in front of x squared. X squared has what's called a coefficient. Now this can be a little bit challenging, but over the next two videos, you're going to see how to deal with this so that it's not going to be a problem. What you need to look at in any quadratic before you try to factor anything is you need to look and see if there's something that all three terms have in common. Now what I mean by in common is this. Is there a number that you can divide evenly into all three of these terms? Do you think you can find it? I hope you saw that in this situation, every single term is divisible by 2. Now what we want to do with this, if we want to factor it, is to actually divide everything by 2. If you remember from the last video, we are actually dividing when you're factoring. You're finding the two numbers that multiply to make your expression. In this case, they're all divisible by 2. Unfortunately, there's no equal sign, so we can't use the golden rule. Hopefully you remember the golden rule.
That which you do to one side, you must do to the other side.
Since we can't do that, we have to find another way to keep this expression equivalent, which means equal. So what we're going to do when we divide this is we're going to undistribute it. Remember, in distribution, you can take a number, any number you'd like. And in distribution, you take that number and you multiply it into each term. We talked about this in the last video as double distribution. So this would give me 3x plus 12 in this weird case right here. What we want to do with this one is the opposite. We want to take all of these numbers and we want to factor out a 2. But really what you can think about this is undistributing a 2. So I can take each of these 2's out, since it divides evenly into all three terms, which means I can rewrite it like this. Notice, if you were to distribute the 2 back in, 2 times x squared gives you 2x squared, which we started with. 2 times 3x gives you 6x, and 2 times 4, or 2 times 2 gives you 4. Now, you always want to try to do this, because now what we can do is these numbers are much smaller, and more importantly, there's no number in front of x squared. So now we can simply take what's left here and factor it like normal. So we would look for two numbers that multiply to be 2 and add to be 3. In this case, there's just one combination, 1 and 2. So my factors are going to be x plus 1 and x plus 2. Now, this 2 out here doesn't go away. It is still in the front of your factor, so don't forget that. Your teachers will be mad if you forget that one. All right, let's look at a couple other places this can be. Again, it doesn't have to be a 2. You can have lots of numbers here. Now, before you do any factoring, you should always check for a common multiple. So in this one, there's another common multiple. It's 3. So what we want to do is we want to undistribute a 3 from each term. I want to factor out a 3 from here, and from here. And if we do that, again, we're dividing each of these by 3, which gives me 3 on the outside. 3x squared divided by 3 is just x squared. This is going to give you 10x. 48, you might not have noticed, divisible by 3, but it is. It's going to be 16. And so now we have another quadratic that we can factor like normal. Notice no number in front of the x squared. All we have to do is factor this, and we can do it. Hopefully you found it out already in your head. We're looking for two numbers that multiply to be 16 and add to be 10. There's a couple of options, 1 and 6, 2 and 8, and 4 and 4. There's only one of them that adds to be 10, it's 2 and 8. So we've got x plus 2 and x plus 8, and that 3 is out in front there. Again, some bigger numbers here. We've got 5 in the front. And what we want to do with this, we want to check every single time you factor. Always check for this. See if there's a common multiple. Is there something that will divide evenly into all three terms? Here, they're all divisible by 5. So we're going to undistribute the 5 from each one, which we can then rewrite as 5 times what's left. So this is going to be x squared, because 5x squared divided by 5 is x squared. Negative 20x divided by 5 is negative 4x. And 20 divided by 5 is 4. And you can rewrite this, you can factor it. We're looking for multiples of 4 that add to be negative 4. And since they add to be a negative, multiply to be positive, we know they both have to be negative. You can check the last video if you didn't remember that rule. But there's only one that works here. It's negative 2 and negative 2. So we have 5 times x minus 2 times x minus 2. And if you're really clever, you can even rewrite it like this. X minus 2 squared. The reason you can do that is because it's the same parentheses twice. That's it for our second episode of our crash course on factoring. Tune in next time, where we're going to find out what happens if you can't factor out a common multiple, but there's still a number in front of x squared.